everyone, so today we're going to be working on 6.2, dividing radical expressions, and I broke it up because this is a little bit trickier, but not too bad. You're going to use your law of exponents. So let's look at our first example. There are some really easy ways to divide radical expressions, and they involve just simplifying fractions with exponents. So looking at this first one, I have the square root of 18x to the fifth and the square root of 2x cubed. Since they have the same index, I can actually divide the numbers. So I know that 2 goes into 18, so I'm going to have 9 in the top. And then x to the fifth and x cubed I can divide. So I bring the smaller to the larger and subtract. So I'm going to bring the 3 up to the 5 and subtract. And I'm going to get 9x squared. All right, so it's the square root of 9x squared, so that would give me the square root of 9 is 3, and the square root of x squared is x. Now, the reason this works is because I actually could write this if I wanted to as 18x to the fifth over 2x cubed. Some of you may want to do it like that so that you can see where I got the 9. 2 goes into 8 9 times. I took the 3 to the 5 and subtracted, and therefore got my answer of 3x. All right, with the cubed roots, as long as the index is the same, you can do the same thing. All right, so I see that we both have an index of 3, so I'm going to check to see if 3 goes into 162. It does, so I'm going to simplify 3 into 162, and I'm going to get the cubed root of 54. I have an x to the fifth over an x squared. I'm going to bring the smaller to the larger and subtract, and that's going to give me x cubed. So I always want to try to see if I can do this before I start doing some of the other tougher methods that we're going to be talking about. All right, so now I've got to go back to simplifying using those multiplication rules. What are my cubed roots? So I've got 2 cubed is 8 and 3 cubed is 27. All right, so I know 54 is actually 27 times 2. So I'm going to take the cubed root of 27, which is 3. I'm going to leave that 2 inside the cubed root, and then I'm going to take the cubed root of x cubed. I'm going to take 3, divide it by 3. It goes in one time, so 3x cubed roots of 2. All right, 50x to the 6th, the square root of 50x to the 6th over the square root of 2x squared. The indexes are the same, so I can divide them. 2 goes into 50 25 times. I see the exponents. I bring the smaller to the larger and subtract, and I get x to the 4th power. All right, I take the square root of 25, which is 5. I take x to the 4th. I divide 4 by 2, which gives me x squared. No more radical because those are perfect squares. Okay, so now we've got to deal with division when it's a little bit more challenging and things don't divide in so nicely. So I want us to recall what we do when we have a radical in the denominator of a fraction. All right, when we have a radical in the denominator, we do something called rationalize the denominator. To do that, in this example, 1 over root 2, I multiply by root 2 over root 2. The reason I'm doing that is because I'm actually making the bottom a perfect square. When I multiply a square root by itself, I'm getting a perfect square. So in the top, I get root 2. In the bottom, I get that perfect square of root 4, which is 2. So root 2 over 2. And that's my answer. So I don't have a radical in the denominator, so I'm finished. Now, it can be harder when the index isn't 2 because we do have to think about the numbers that make perfect cubes. All right, so if you look at the denominator here, I have a 4. Well, my perfect cubes are 2 cubed is 8 and 3 cubed is 27. So I want to make the denominator a number, one of those. So I can make the denominator 8. How? I'm going to multiply this by, hold on, let me erase that. I'm going to multiply this by 2. Okay, so 2 times 4 is going to give me 8. All right, I've got to make that y squared also a cube, so I need to make it 3. So I'm going to multiply by a y. That's going to, when I power times the power, we add the exponents. All right, and then the z, I'm going to multiply by z squared. All right, now whatever I do to the bottom, I have to do to the top of the fraction. So I'm going to do that as well. Now I'm going to multiply and keep everything under the root. So that's going to give me in the top 10 x squared y z squared. And in the bottom, it's going to give me the cubed root of 8 y cubed z cubed. All right, so now I can simplify the bottom, and it's going to give me the cubed root of 8 is 2, the cubed root of y cubed is y, and the cubed root of z cubed is z. There should be no radical in the denominator of that fraction. The top, I look and see if I can simplify it, and 10 is not a perfect cube and cannot be reduced. X squared y and z squared cannot be reduced, so I would leave that in the top of the fraction. All right, let's try another one. Cubed root of 2x all over the cubed root of 9x to the 5th z squared. Again, I'm going to think of my perfect cubes. 2 cubed is 8. 3 cubed is 27. I look clearly at the number. What could I multiply this by to make 27? Well, 9 times 3 is 27, so I'm going to multiply the bottom by 3. Also, I need to make x to the 5th a perfect cube, which means it needs to be 6. It needs to be divisible by 3. So I'm going to have to multiply by 1 more x. Z squared, I need to make a 3, so I'm going to have to multiply by 1 more z. All right, whatever I do to the bottom, I have to do to the top. All right, now these are cubed roots, so I'm multiplying them within their cubed roots. So it's 6x squared z all over the cubed root of 27x to the 6th z cubed. All right, I'm going to simplify. So now the top does not simplify in this case. And the bottom becomes 3x squared z. And that would be my final answer. I know it looks funny, but you did a great job simplifying if you got all through that. All right, we're going to do one more, okay? One more. Cubed root of 5 over 3x. Now, you may notice that I didn't write it as separate roots. I wrote it as a single root. That's okay. So I have to multiply that bottom because this really means the cubed root of 5 over the cubed root of 3x. That means I have a radical in the denominator. Just looks a little different, okay? So I'm going to multiply the bottom by, it looks like 9. I want to make it 27, and an x squared to make it x cubed. I'm actually going to extend that so you see that's what I'm really doing. All right, so in the top, I get the cubed root of 45x squared. And in the bottom, I get the cubed root of 27x cubed. I can't simplify the top because there's no perfect cube in 45 and there's no perfect cube in x squared, so it stays as the cubed root of 45x squared. The bottom, however, is the perfect cube because that's our whole point of this, and we get 3x. All right, so now you are going to try, and you've got this, okay? So first you're going to check to see if they're divisible before rationalizing. You only want to rationalize under the last resort. All right, so you're going to try, pause, try 18 and 19, come back and check your answer. All right, you're back. This should have been the root 25, which was 5, because 3 goes into 75, and they are the same index, so you can divide them. Number 19, same thing. It had the same index. I see that 7 goes into 63 9 times, and I'm going to simplify the y's, so it's going to become 9x y squared. All right, then I simplify that. Square root of 9 is 3. X has to stay in jail because he is not a perfect square, and then y is, so she comes out. So 3y root x. All right, now I want you to try rationalize. So number 23, okay? Go ahead, pause, and try it. Okay, if you're back, you multiplied by the denominator, make the bottom a perfect square, and you got root 5y over 5. Top can't be reduced, and that is all. All right, I want you to jump to number 25 and try it. This is the harder one. This is the cubed root. Now remember, I'm multiplying by another cubed root, but I'm just not putting it in the cubed root, okay? So I want to make the bottom a perfect cube. Pause and try. All right, you're back. So hopefully you multiplied the bottom by 2x. And really you're multiplying by the cubed root of 2x. I'm just not showing that because it gets really confusing when I do that. All right, so 2x. The top you're going to multiply by 2x. That's going to give me the square of the cubed root of 14 x squared y squared. And in the bottom I'm getting the cubed root of 8x cubed. Simplifying the top, it doesn't simplify. So 13 and then 4x squared y squared. On the bottom, you're going to get the cubed root of 8 is 2. The cubed root of x cubed is x. So hopefully you got that answer. And tomorrow we're going to be doing some more practice and some more review. Okay, see you tomorrow, guys.